10.5 is an ANOVA test, and this compares several sample means. So ANOVA means analysis of variance. It compares several sample means at once, and it avoids problems with using multiple tests to compare groups of data. For your ANOVA test, it determines the existence or non-existence of a statistically significant difference among the group of means. So as we go through this, it's very similar to what you did in Chapter 8. However, it gets a little more complicated because you're going to have a lot more data pop up that you're going to have to record too. So going through this, your null now is not just going to be mu1 equals something. It's mu1 equals mu2 all the way up to however many groups you have. If you have 5 groups, you have 5 mu's being equal to each other. Because we're saying in the null that all the means are the same. Then your alternate, you can just write not all the means are the same, or not all the means are equal. So we are testing in our alternate that there is some difference among the means. So again, we're going to find an F statistic this time. We'll find a p-value. Same thing though, if p is greater than or less than, we have the reject, we have the do not reject, just like we did before. So for the calculator, you hit the stat button, you have calc, and you're going to enter your numbers into your L1, L2, L3, so your stat, your edit, like we have gone through. And then we have our stat test ANOVA to get our list. Okay, so here we've got a psychologist is studying the effects of dream deprivation on a person's anxiety level during waking hours. Brainwaves, heart rate, and eye movements can be used to determine if a sleeping person is about to enter into a dream period. 3 groups of subjects were randomly chosen from a large group of college students who volunteered to participate in the study. Group 1 students had their sleep interrupted 4 times each night, but never during or immediately before a dream. Group 2 subjects had their sleep interrupted 4 times also, but on 2 occasions they were awakened at the onset of a dream. Group 3 subjects were awakened 4 times, each time at the onset of a dream. This procedure was repeated for 10 nights, and each day, all subjects were given a test to determine their levels of anxiety. The data in the table record the total of the test scores for each person over the entire project. Higher totals mean higher anxiety levels. Use a 5% level of significance. So first off, plug those into your L1, L2, and L3. So stat, we've got our edit, go up and clear. So I've got 9, 7, 3, 6, 8. Okay, so we type all our numbers in. We're going to hit the stat button again, and we're going to go over to tests. Now, ANOVA is going to be at the very bottom. So you're going to scroll down and scroll down a lot. And it's H for me, so I want ANOVA. So we're going to hit enter. Now, after that parenthesis, you have to say what groups we're looking at. We put numbers into L1, L2, L3. So you go second 1, hit the comma, second 2 to get your L2, hit the comma again, second 3 to get your L3, and then end your parenthesis. Hit enter. And you have a nice long list of stuff. So we're going to make sense of what all those numbers are. There is a method of a long formula to figure out what your p-value is and what your F statistic is. You are not going to have to go through and do that for me. You're going to be able to use your calculator to find it instead. But that's what all these numbers give you, so you could find it by hand too. So the null and the alternate are always going to be the same for these. We're going to say for the null, all the means are the same. So mu1, mu2, mu3 is equal. For the alternate, you can just write in words too. Not all the means are equal. And then for our alpha, we are 0.05. Now your F ratio, which is your F statistic there, is going to be 8.212. Your p-value here is 0.0039. Again, WebAssign will tell you how many decimal places that you need. And they want to know if this test indicates we should reject or fail to reject the null. So remember, your p-value is going to go on the left. Your alpha goes on the right. And we are less than. If we're less than, we're going to reject the null. So if we reject the null, we are going to say that from this data, at the 5% level of significance, there is enough evidence to conclude that not all means are the same. Now, we have a summary table for this ANOVA test. That's where all the numbers are from your calculator there. You have to plug them in the parts they go in. So, I need you to write where it says between groups, that's going to be the factor part. And where it says within groups, that's your error part. So when it says factor sum of squares, you want the factor SS. So if you notice then, the 70.038 is the same thing as the factor SS in our calculator. Where it says factor DF, that's your degrees of freedom. 2 and 2 match up there. When it says the mean square, that's the MS. If you look at factor MS, that's your 35.019. Your F ratio is our 8.212. They have 8.213, just however they rounded. Our p-value, we saw our p-value is 0.0039, which they say is less than 0.01. And their test decision is what we decided to reject the null. The next row, they have the within groups, that's the error. So now if you scroll down, you can find your error SS. So your error SS was the 63.962. Your error DF is 15. And then your error MS is 4.264. Now to get your totals, you're going to add those two together. It should give you that 134. Add those two, it should give you that 17. On your actual test, you will not have to do this for me. However, on WebAssign, you are going to have to fill out this whole chart every time. So that's why I want to make sure that you know what goes where on this chart so you can get all those points on WebAssign. WebAssign is going to be like 100 points, but just filling in this table is going to give you like 10 points every time and going through all your parts. So it's not like it's a super long assignment. It's just typing all the numbers in. Now, I will also tell you on WebAssign, they get really picky on rounding. So you need to make sure that you are going to double check all of your numbers in your calculator first. If it's still telling you you're wrong, send me a message on WebAssign. We will make sure you get all your points. So make sure all of your numbers were typed in right first. Then go through and message me and we can double check numbers. You will see there are a lot of parts that get confusing with WebAssign with this section. So if you need to look at my problem I did with WebAssign, if you notice, if you go to our page and you look at my WebAssign help, I do number 1 with you. So if you have questions on how we're getting any parts of number 1, it's all there for you with all my numbers. Our numbers might be different, but you can at least see what I'm putting into the problem, how I'm getting what I'm getting. Because they're going to go step by step through these problems because they're expecting you to do it by hand. Like I said, We are not going to require you to do it by hand. You can do it all on your calculator for me. I just do not want you to get frustrated with this section because this is a fairly easy section. The hard part is just going through and typing everything in your WebAssign correctly. Okay, I want you to try this one. So a psychologist is studying pattern recognition skills under 4 laboratory settings. In each setting, a 4th grade child is given a pattern recognition test with 10 patterns to identify. In setting 1, the child is given praise for each correct answer and no comment about wrong answers. In setting 2, the child is given criticism for each wrong answer and no comment about correct answers. In setting 3, the child is given no praise or criticism for each wrong answer and no comment about correct answers. In setting 3, the child is given no praise or criticism, but the observer expresses interest in what the child is doing. In setting 4, the observer remains silent in an adjacent room watching the child through a one-way mirror. A random sample of 4th grade children was used, and each child participated in the test only once. Test scores, number correct for each group, are in the table. Use a 5% level of significance. So again, I want you to go through this on your own. You're going to now have 4 groups, so you're using L1, L2, L3, L4. So pause the video, type things in, at least fill out everything, and if you need help, we can do the backside together. Okay, so you should have first started editing and clearing everything out. And like I say, always double check your numbers. Nine eight eight nine 2543 937 856 Okay, so we're going to hit stat. We're going to go over to tests. Now, if you haven't figured this out, if you move the up button, you're going to go to your ANOVA because it's the last one. So if you go up, it's the bottom one there then. So I've got 1, 2, 3, 4. I have my parentheses there. There's all my numbers. Okay, so for your null, we're saying mu1 equals mu2, mu3, mu4. We're saying not all means are equal. We're not saying they're all different. We're just saying they're not all equal. So 3 of them could be equal, but 1 of them might be different. So that means they're not all the same. And our alpha is 0.05. Our test statistic is the F. Again, however many decimal places WebAssign tells you. Your p-value here. So I've got 0.0048 is smaller than 0.05. So we're going to reject our null. Okay, for your summary table then. So you have the between groups, that's your factor. Within groups, that's your error. So my SS is my first column, my DF is my second, and then you have your MS. So you want to find the factor SS. And then we want to find the factor DF and the factor MS. Our F ratio, our p-value, And our test decision, we said reject. Then we're going to the error. My DF there is listed, so that's 16. My SS, my MS, and like I said, WebAssign will tell you what it wants you to round to. Now for your total, you're just going to add the first two columns there. So when you add those first two, you get a 92.95 and a 19. Again, they're asking you to find all this because this helps you figure out what your F statistic is. But again, calculator will tell us for it. Now we're going to state our conclusion. So you will have to write a sentence for me with this on your quiz and test. So at the 5% level of significance, again, starts off just like our chapter 8. There is enough evidence to conclude that not all means of test scores of the different groups are equal. So we're saying there is enough evidence to conclude that the means are not all equal to each other. That's basically what we're saying. And we'll make sure you're having this relevant to what the problem is too. So we're talking about test scores. So we're saying that there is enough evidence to conclude that not all the means of the test scores of the different groups, sorry, I write too fast, different groups are equal. So again, don't struggle through 10.5 with WebAssign. Send me messages if you need me to. I can look at what you're doing. Just don't wait till the last minute because then I can't respond back to you. So make sure you work on this ahead of time so I can respond back to your questions if you got them.